to find a derivative using the quotient rule, chain rule, or product rule. And today we'll probably stick with this. Here's example 1. On this example, y equals 3 to the negative 2 power plus 4x squared over 6x to the negative 3. Now, if you start off with the quotient rule right off the bat, you would put that denominator up top and multiply it by the derivative of the top, and then reverse the process after you subtract in the middle. Or you could run through and simplify everything first before you even have to do a derivative. So let's simplify first and just keep it y equals. On the top, that would be 3 over x squared. And then the 4x squared stays the same. On the bottom, that would be 6 over x to the third. Now the bottom is not worrisome yet, but the top must be changed. You need a common denominator between x squared and 1, and that common denominator is x squared. So your 3 over x squared would not change. But the 4x squared, to get a x squared on the bottom, you would multiply by x squared, but you must multiply the top as well by x squared. And that's why it becomes 4x to the fourth, because here we've multiplied the top and the bottom by x squared to get a common denominator of x squared on the bottom. And then on the bottom you have 6x, or 6 over x to the third. Now from there you can first change colors so all this doesn't bleed together. There we go. We're going to go up here, and you're going to add together this and just put it in the numerator of a fraction, and put the 4x to the fourth first, and then plus 3. All of that is over x squared. We've added those fractions together. On the bottom you still have 6 over x to the third. Now if you're dividing by a fraction, that's the same as multiplying by the reciprocal of that fraction. So you would have 4x to the fourth plus 3, all of that over x squared, staying the same. And then multiply by the reciprocal of the bottom. And when you do that, that will allow you to cancel x squared and x to the third by leaving just an x on the top there. And multiply this x by these items to get 4x to the fifth plus 3x. And then on the bottom, you'll have just a 6. Now with this, you can easily find a derivative as opposed to doing it right off the bat over there. If you like the first way, you can keep doing it. If you want to do it this way, that's fine. On the next page, I'm going to recopy this, and then we'll find the derivative. So now what we want the derivative of is going to be y equals 4x to the fifth plus 3x over 6. Now you could use the quotient rule, but it's not necessary. You can break these up as the following: 4/6 x to the fifth plus 3/6 x. And before you go any further than that, you can still simplify. 4 over 6 is 2 over 3. And 3 over 6 is 1/2. Now find the derivative. So y prime, for the 2/3 x to the fifth, if you bump that 5 down from the exponent and multiply it by 2/3, you get 10 over 3 x to the fourth. And then for the x over 2 here, remember that's the same as 1/2 x. Looks like an e on the bottom. That's supposed to be a 2. So the derivative of that would just be a half. And from there, I really don't want mixed numbers, so we'll just set the rule now that we leave them as improper and reduced. Find the derivative of this. this is negative 2x to the negative third power minus 4x to the negative 2 over 5x to the negative 3 power. To start on this, you should simplify first, and on the top you would have a negative 2 over x to the third, and then minus 4 over x to the second. On the bottom, 5 over x to the third. On the top, you need a common denominator, and we'll make that x to the third. So you would have to multiply by x on the top and the bottom. So when you do that, that's negative 2 over x to the third minus 4x over a poorly written x to the third. On the bottom, 5 over x to the third. Now we have to combine these items together, and let's make this negative 4x over x to the third and then minus 2. And I was supposed to combine these. I did not do it. So I'm going to cheat and make that part of the minus sign and put the minus sign there and just leave that x to the third in an awkward position on the bottom. And then we have 5 over x to the third. Now, what we can do is have negative 4x minus 2 over x to the third times x to the third over 5. And that will allow us to cancel here and there and be left with negative 4x minus 2 over 5. And we'll go find the derivative of that on the next page. Hopefully I can remember it without writing it. And that was y equals negative 4x minus 2 over 5. Okay. Break that up as negative 4/5 x minus 2/5. And when you go to find the derivative, you would have a negative 4/5, and that's it. Find the derivative of this expression. 10x to the negative fourth plus 5x to the negative second over 20x to the negative sixth. Alright, let's simplify first and make this 10 over x to the fourth plus 5 over x to the second, and on the bottom 20 over x to the sixth. A common denominator of x to the fourth means we need x to the second over x to the second here. So 10, and we can combine on this step if you want to. That would be 10 plus 5x squared, and all of that over x to the fourth. And on the bottom, that would stay the same. Now, up here in a different color, we can have not enough room. I doubt it, but I'll try. 10 plus 5x squared over x to the fourth, and then times x to the sixth over 20. And from there we can cancel out to have an x to the second on the top. So we multiply across to get 10x to the second plus 5x to the fourth over 20. And that should be a y equals there. Then, when you separate the two, you can have 10 over 20, that'd be x squared, then plus 5x to the fourth over 20. Reduce that to 1/2 x squared plus 1/4 x to the fourth. And from that, you can get a derivative, which, as luck would have it, I have enough room here, hopefully, to put it in. When you bring this down and multiply it by 1/2, you get a 1. And drop the exponent down to 1. And then on this one, bring that down, and it becomes 1/4 times 4, which is 1. And then you'll have x to the third. Technically, you should write this one first and then this one, but I'll take either one.